Patrick. Welcome to my stand-in session for Entity Framework Core and persisting data, because it's one of those things that most people want to get into and they just don't know where to start and where to begin, because databases is like a whole subject that most people don't actually want to get into when they're just trying to program. So I'm trying to make this as sort of as painless as humanly possible to kind of new people into programming in C# in general. So we're going to be going into Entity Framework today. I'm going to be starting a new project, which is just going to be a web API. We're going to pretend like there's going to be some kind of consumer on the other end, like a mobile app or just a third party who's interested in getting some data from us. So we're going to get started a very bare bones kind of web API that you can get from ASP.core today with the ASP.core web API. In terms of the sort of the setup, we're just gonna have like the general template setup with Swagger doc and the Swagger UI, which will let us kind of debug and do some bits and pieces here and there to actually get Entity Framework to kind of collaborate with what we're trying to achieve here today. So let's just give our solution name Web Application 1, because we're going to be building the next big thing. And really the kind of the first question to sort of in anyone's mind is, well, why use Entity Framework? And the reason is you just don't want to write SQL. Like that's the short of it. It's a language that you're piling on top of your knowledge stack that you already need to expand because you're learning C#. You're trying to learn all these frameworks. You're trying to learn .NET. What does .NET mean? What does .NET Core mean? What does .NET 5, .NET 6, 7? What does .NET Framework mean? Where's .NET Stand fall into this? And then suddenly you've got databases, and suddenly you've got, well, what's a relational database? What's NoSQL? Where do I host it? You know, do I do a direct database connection? Do I have any amounts of questions that come from that? And we see that all the time in the server. So why use Entity Framework? Well, it's a C# library that allows you to crudely connect to your database and get some data. So everyone's favorite weather forecast app has now been started. If I press F5 on this, and I realize my ID has reset to dark theme, so that's cool. We'll just get the regular kind of Web Application 1 Swagger, right? This is my setup. We're not going to go any further than that to make a web API right now. So the first step is to install Entity Framework. And how are we going to do that? Well, it's distributed via NuGet packages. So if we go to the NuGet package manager and we just type in Entity Framework Core, you'll grab several packages, but this is kind of where your first decision already has to be made. What kind of database are you going to connect to? And that in itself can be quite a topical question, quite opinionated, quite controversial in some reasons. Out of the box, there are several engines that Entity Framework supports. It's Microsoft SQL Server, SQLite, which is a file-based approach, Cosmos DB, which is a kind of a document database offering from Microsoft, MySQL, and Postgresql, which is kind of the open source loved alternative to Microsoft SQL Server. So really, in my opinion, you have two kind of main contenders. You have Postgres and you have SQL Server. Most people will opt for Postgres because it's free, it's open source, and it works pretty much as well as you would expect a database to work for you. For today, and if you're following along or you just want to get working and you just want to persist some data to some kind of storage medium, we're going to use SQLite, because literally anyone can get started. You don't need a server. You don't need to worry about where it's going or what you're doing. You're just going to have a file which keeps all your data in there. And Entity Framework will react exactly the same way with that file as it would with a server. So let's install Entity Framework then. We're going to start with the kind of the base package, which is just Entity Framework Core. Accept that as per usual. And then we just said, well, we're going to use SQLite. So luckily, there's a package for SQLite. There's kind of modules to Entity Framework. At this point, we'll install the SQLite module. And then we also want to install the design, which I'll get to in just a moment as to why I'm doing that. So I've got three main packages I've just installed here: Entity Framework Core, Entity Framework Core SQLite, and Entity Framework Design. These three packages are going to make up the core, pardon, of my kind of interactions with Entity Framework. So let's go to our program, which at the moment hasn't got any idea that we're going to be doing anything with Entity Framework, and our application doesn't have anything to do with Entity Framework because, well, all we've done is install a package. So the first thing is we need to make our application aware of Entity Framework. So I'm going to do this by adding a new folder. You can structure this however you want, but for the purpose of this, we're going to make a data folder. And then we're going to make probably the most important class in your entire code base, which is going to be the context class. And we're going to call this solution1 context. And what the context class is a C# representation of your database. And importantly, we're going to inherit for something called a DB context, which is the sort of the preferred. You can implement from other classes, but this is the preferred kind of base implementation Entity Framework will provide you in order to do all the magic. And from this, we're now going to explain to Entity Framework what our database is going to look like. So of course, in relational databases, we have tables, columns, rows, etc. So we need to tell our application that, okay, we've got Entity Framework, and then we're going to tell Entity Framework, okay, we're going to have these tables. So today, we're going to design a bit of an event system because we've got solution1 going on, and maybe in the future, we want to have future conferences. So we want to obviously consolidate all these into one area. So we're going to create a class, which is going to represent one of our tables in our database. And we're going to call that class event because we're trying to represent events. I'm trying to model the real world, so I'm just going to model an event. And our event is going to have a couple of properties. We're going to have an ID, and we're going to have a name. And we're going to have a description as well. Now, you'll notice that I've kind of got an ID here. It's not typical kind of object-oriented programming. The reason I have an ID is this is where the database sort of paradigms come into play here. Every row in your database typically has a unique identifier. In this case, it's quite literally an ID column. And this will be used to identify a particular row in my table. I might have millions of events. I might have one event, two events. It doesn't really matter. But each event will have its own unique identifier, which in my case is just going to be a normal, integer. It could be a string. It could be a GUID. It could be any kind of type that's kind of supported in your database engine. I'm also going to have a name, which is going to be required by default, which you're going to use the new C# 11 features. And then I'm going to have a description, which we're going to make optional because you might want to put a description later on. So that's going to be my event class. And then I also want people to attend my event. So let's make it a event attendee. And this is going to take much of the same shape. So I'm going to have another ID. And we'll have a name there as well, because obviously the person wants to be required. So we're going to make this required as well. And then I obviously want to say that this person attends a specific event. So at the moment, I have a class that's completely detached from my event, but I need some way of linking that back. Now, in regular C#, you might just say, well, okay, I'll just have an event property, and then I will make that basically almost like a dependency of event attendee, which of course is the case because I can't really have an event attendee without an event. Now, in Entity Framework, there's a bit of a paradigm for this. We would have this property still, and we refer to this as a navigation property. That means that I can navigate from event attendee to event. Cool. The database also needs to know about that. I can't just store a C# object in my database. I need some way of, in my relational database, I need some way of navigating, back and forth, if that makes sense. So we do that by specifying what's known as a foreign key. And we say, okay, our foreign key is going to take our form, another property, this time an integer of event suffixed with ID. So you'll notice that my navigation property, my event, is just called event, and then my foreign key is called event ID. Now I'm going to make this nullable, and I will explain why when we get further down the road, but you'll see my foreign key isn't nullable. So I'm saying that an event attendee has to have an event ID. So I'm now describing to Entity Framework that event attendee can't exist without an event. So that's cool. Now, navigation properties go both ways. So on the event, I would also have a collection of event attendee. And this sort of now allows me to navigate back and forth. I can go to my database and grab a specific event by its ID and then get me all the attendees for that event. Or I could grab an attendee and figure out what event they're actually going to. Patrick's going to solution 1. Obviously, I need to know that. I can't just have event attendees in my database without any idea where they are. But that's sort of the starting steps of representing your relational database in C#. So now I've got these two classes. It's all well and good, but Entity Framework still doesn't know about them. I want to now tell my context, which is basically my database, that these two tables exist. So that's done by specifying a DB set of event, and we'll give the table name events. And then we'll also have event attendee, and again, attendees. Now, by default, that's going to be plural because I hopefully have many events and hopefully many attendees. We're just going to make these init as well. Use the lovely new features of C#11. There we are. Cool. So now I have a solution 1 context. It has two properties in that, and they're both DB sets. I've got DB set of type event and a DB set of type event attendee, and it's describing what my database is going to look like. Now, the last thing we sort of have to do at this point is tell Entity Framework how to connect to our database, and that's done through connection strings. So if I override a certain method in here called onConfiguring, I'm given an option to build off of an options builder, which is going to configure Entity Framework for me. And I can say, options builder, use SQLite, which is the package that we installed in order to tell Entity Framework to use. Now, at this point, I could substitute in any of the other packages. If I installed the Postgres package, I would say use Postgres. And then I would specify a connection string for my Postgres database. It just so happens that in this case, I'm using SQLite, so I'm going to specify a connection string that's relevant for SQLite. And I'm going to give it a name of solution1.db. Now, if you don't know what SQLite is, it's going to generate a file for me, which is, for all intents and purposes, just my whole database in one file. And I'll give it the name of solution1.db. It could be anything. I could literally call this solution.1 and it would still work. It just so happens that I want to be quite explicit about my name here in this case. So now I've told Entity Framework that I'm in this data source, which is solution1.db. And these are my tables, and this is my database. Okay, so that's all well and good, but I don't actually have my database yet. If I run this, nothing will happen. It will still build. Everything's fine. My application still doesn't really know that Entity Framework exists. So happily, Entity Framework core works really well with the Microsoft dependency injection container. So if we go, say, build.services.add DB context, I can specify a type of context, and I've just created my context. So we'll just say solution1 context. And now I can use my context as part of the dependency injection pipeline, if you will, of ASP.NET Core. And now my context is available everywhere, and I don't have to worry about its construction, and it will always be configured to go to SQLite, and we'll have my tables, and now I can start doing some stuff to my database. And that's great. That's all I want. I still have the problem, though, that my database doesn't actually exist. So what do I do? Like, I could go off and try and figure out how to create my database, which is, totally doable. I can go and make a SQLite file and try and make sure that the columns match the properties in both my tables. But I'm kind of lazy, and I'm using Entity Framework. So let's get Entity Framework to do it. So there's two approaches to Entity Framework. There's DB first, and then there's code first, which is also sometimes referred to as migrations. I'm going to fully leverage code first here because I'm a lazy C# developer and I just want to get some data persisted. So we're going to go into our directory for this application. And what we're going to do is specify that Entity Framework should look at my context, and it should look at my event, and it should look at my event attendee and generate a migration to create my database for me. So if we go into our Explorer, wherever you might be, Mac or Linux, and you specify to EF to look at this, it can generate your database for you. And you can do that by installing the global CLI tools for EF. Well, I suggest you make it global because you're going to be using them probably everywhere if you're using EF. So if you do .NET tool install .NET EF-G, I've already got it installed. So it will install the .NET tools for you. And then you can just access EF's CLI by doing .NET space EF, which is great. So now I can do .NET EF migrations add initial. And what this will do is essentially marry my context I have here, my solution one context, to a known sort of output for SQLite in order to make a file, if that makes sense. So if I run this now, I'm going to say migrations add, and I'm going to give it a name, which in my case is initial. It could quite literally be anything. It could be solution one first migration. Just to prove the point, I'll use that now. So I'll press enter. It's going to build my project for me. It's going to try and execute it, look at my context, look at those classes, and it's going to spit out into a new folder called migrations, two very important files on the first run. It's going to spit out solution one first migration and solution one context model snapshot. This file here is a C# instruction set for how to perform operations to get to the state of your C# context. That was a lot of words, and I'll break it down. But you can read this and you can edit it. It's totally fine. It's auto-generated code, but you can edit it, and it's in fact it's better if you read this and validate it, because EF is still going to make mistakes. But you can read it and see it's going to create a table for me called events. It's going to create a column called ID. It's going to take the C# type, which in my case is an integer, and map it to the SQLite type, which happens to also be integer in this case, not make it nullable. And it's also going to add some annotations here, which are database specific, which I won't go into now, but auto increment, which, well, it just means that the number will increase for me server side or database side. So I don't have to worry about making my own ID. I've got a name column, which is C# as a string, and that's going to go to the text type in SQLite, because that's what they call their string. And then you can see it does the same thing for event attendees, and it builds up the operations, which you can read and you can modify, and you can say, well, I don't want it to do that, or I want it to do something else. I want it to do this X, Y, and Z. But this is all good. Where's my actual, like, how does it now happen? How does it know what to do? How does it know what to generate? And how is it not going to generate this all again on the second try if I now make solution one second migration, right? So if I just run this again, how is it not going to generate all that again? How does it know that, well, I've already got a file for that? Does it just read the entire file again? How does it scale? How is it going to? No, it uses this solution one context model snapshot. So you see that my second migration is completely empty. Like, there's nothing for it to do. It's like, well, how does it know that? In my model snapshot, it's built a full model of what my database should look like in an ideal world, assuming you haven't screwed up anywhere else. And it will specify everything it expects to see. So it's expecting to see an ID, a description, a name to a table called events, and it's expecting to see an ID, an event ID, and a name on event attendee. And I've fulfilled all that. I've got all of that. Doesn't need to be changed. If I made a change to my class, EF would see that, and we'll go into a bit more detail later on for that. So for intents and purposes, I can just get rid of this last migration because I don't need it. So we'll just type remove. And then that will remove the second migration that was empty. Cool. Right. How do we now apply that? Well, there's a couple of ways of applying it. I'm going to be a bit lazy and tell my program to apply at startup, so I don't have to worry about it. All I have to worry about is generating the migration. So handily, there's an API for just applying migrations. So we'll create a scope with our service provider, and we'll try and get a database context. Once we have our context, we can just say database context.database.migrate. And now what will happen is it will look at the migration files and apply those. Some people are going to immediately scream at me and say, why aren't you doing this async? Well, I'm not, because it's the startup and I don't really care for it to be async right now because it's a SQLite file at the end of the day. There are async APIs for this. Please don't scream at me. But what this will do is it will tell the application to now go look at what migrations need to be applied and make my file for me. So now if I just go and put a breakpoint in, I press F5 on my application, what we should see is that out here in the working directory of my application, I'm going to press migrate, and suddenly I have my database file just generated for me. Perfect. That is all I wanted. Now as a C# developer, I'm a successful DB admin. Don't believe me? We can go look at the file. Now, unfortunately, we can't just open this in Notepad as much as I'd love to. But there's a handy tool out there which I can link. It's just a DB browser SQLite. It's fairly well known at this point, cross-platform. But I could just drag this file in, and then you can see if I look at my database structure, I've got my events table and my event attendees table, which is exactly what I wanted. And then there's also a third table, which I haven't specified, and then CFramework just decided to go and make for itself. Why has it done that? Well, this is how Entity Framework tracks what migrations have been applied to your database. If I go to this this table, you will see that it's recorded the migration ID, my solution 1 first migration, and the version, which is less important. But it's recorded the fact it's run this against the database. So the next time this happens, next time I run my application, it's not going to bother running it because it's already run that migration. So that way you won't get errors and whatever it might be. So that's a very crude and very whirlwind example as to how I can get started very quickly to a database file. So that's perfect. So now I can run my application and it's happy. I'm obviously not doing anything yet, but now I've got my file. I can kind of rest assured that I've got something there at least. Cool. So unfortunately, now we're going to delete everyone's favorite weather forecast, and we're going to look at actually making a controller, because that's what we're all here for. I'm going to just reuse this, and we're going to first of all look at sort of, well, what are we trying to now do? We're trying to get events into our database, so we'll have an event controller. We'll take out the logging, but we know immediately that we're going to need our context that we just had. So we'll inject that. And you see, I'm literally just saying, grab me the instance of my solution 1 context. That's all I'm doing. And the Microsoft container will resolve that and give me a scoped context. And we'll get more into kind of what that kind of means for you later on. But I've now got, for all intents and purposes, a opportunity. Doesn't have to necessarily be a realized opportunity, but an opportunity to connect to my database. So we're going to return an IEnumerable of event now. So that's my domain model. And we're just going to say, okay, return solution 1 context events to list. Perfect. We're here. Now, in the context of a web application, and because you are most likely going to be connecting over the internet or some way to an actual database, doing some MyO stuff, whatever it might be, you will 99.99999% want to have things be async. And all the APIs in EF are both synchronous and async. And for the purposes of kind of best practices for a web application, you're going to want queries to be async pretty much all the time. I can't, off the top of my head, really think about a scenario where you would want to block. Certainly not here at the moment. So we're going to change our toList to toList async and await this. Perfect. Good. Okay. So that's nice. So now we've got an endpoint that brings back everything. We're also going to have a post, and this is going to add an event. And we're actually just going to return the event that was added. So that's fine. And then we're going to take from body. And we now want to get that object into our database. How are we going to do that? Well, okay. This is where you really start to benefit from an ORM and just C# APIs. I can just take that object and just put it into my database. I don't have to worry about it. I can just go solution 1 context.events.add model, and that's it. course, I need to tell my database to save now. So every operation that you actually want to commit to your database has to be followed by save changes, in this case, async. But for all intents and purposes, I have now added straight away from a web request my model that I'm getting from a web request straight into my database. And that's all I'm going to do. I'm not going to run this. And you can see it's trying to migrate again on startup, but it won't do. I've got my two points now. I'm going to try this out, and I'm going to say, okay, my ID. What's my ID going to be? Well, I actually don't care about setting the ID. And we're going to talk in a moment why I've now exposed something to the consumer of this API, which isn't preferential to the usage of how I want them to use my API. But we're certainly going to give it a name. So in this case, we're going to give it solution 1, and the description is going to be the best C# conference in the world. And I don't have any attendees yet because I'm only just started this event, and I have no idea if anyone's even going to attend. It might just be no one wants to come see my EF talk. Who knows? So that's fine. I'll just basically post an empty JSON list array to my endpoint. So if I execute this now, I got my 200 back, and I've got my event back. And you will notice that suddenly, even though my ID was 0 up here, my ID has now become 1 in my response. So how's that happened? Well, what's just happened is I've taken my object, I've told Entity Framework to add it to my table right here. Importantly, this is currently still in memory. And then I've told Entity Framework to, okay, well, now I'm going to save changes. So now that I've told it to save changes, it's going to look at everything that's happened in the context. So I've got my instance of my solution 1 context. I've told the context that I'm going to add an event to my events table. When I call save changes, it's going to look through the entire context. It's going to look for everything that's changed. And in my case, it's just one thing that's changed, a new record, and it's going to commit that to my database. So now if I browse my table, you'll see that I have 1 record in here, and it's solution 1 with an ID of 1 and the best C# conference in the world. And I got an ID of 1 because I'm letting the database, or SQLite in this case, manage the ID for me. And that's cool. I don't have to worry about IDs. Now, in most database engines, you won't actually be able to set an ID unless you explicitly configure EF to do such a thing. You could, if you really wanted to break this now and you ask me the question of what happens if I do this, you can actually do this in SQLite. And I now have a record that has an ID of this. And now the next ID will be 384747. That is not preferential. Like, I do not want my consumer of my API to be able to do that. Why would I want them to be able to set an ID? Like, I don't, an ID is just an identifier for the row, right? They could do this, and they could intentionally try and break my API because I'm being optimistic and just using a dumb integer. And then suddenly I've got problems on my API side. And I mean, this is an ASP not core problem, but, or JSON serialization, I guess. That's not like, why would I want that? And the problem is I'm currently exposing and tightly coupling my database models to my consumer. I have said, this is what my database looks like, and you just deal with it. And that's not how the real world works. You don't expose everything, you don't expose everything about yourself to someone else, as bad as that might sound. But dealing with specifically model classes for Entity Framework and anything for your database, really, in your domain, you should never expose it publicly. Now, there's a bit more of a philosophy behind that goes beyond just Entity Framework, but you should not send your entities over the wire, ever, in any case. And I argue, even if you're building a small application that is just a toy or proof of concept, you shouldn't be doing this. Ironically, I've done it because I'm trying to prove a concept, but trust me, you shouldn't do this. So how do we get around that? How do we, what are we doing to get around that? Well, we're going to, instead of tightly coupling our database to our consumers, provide some kind of other contract to our consumers. And we're going to do that by having another class that kind of sits there, represents what we want to have, but we won't necessarily materialize and push straight into our database. So in our case, we're going to have something called a DTO, and we're going to use records for that. So I'm actually going to, call this event DTO. add event DTO. And now I have to make a decision about what do I want from the consumer. Well, I want a name. I want probably a description. And that's it for now, I think. I don't need any more than that. So we're going to return that, and we also want them to post to us a model. Of course, that's immediately going to break because EF is now type safe and says, well, my events table is an event class, and you're giving me an add event DTO. Like, how do I shift that? I mean, this just goes back to regular C# now and say, well, we're going to turn that event DTO into an actual event for our database to consume, right? So we're going to just say event entity equals new event. And we're just newing up our event entity class, and we're going to give it a name, which in our case is model.name. And our description, which is going to be model.description. And there we go. Then we say, add that to our database, and we've fixed the build errors. Perfect. Does this still work? We'll find out. We're now being very explicit about what the consumer of our API can expect and should post. And you'll see that now I've fine-tuned this to just be a name and description. So if I have a mobile app, I would just have two fields in my mobile app UI, and it'd be name and description. If I now go to my post and I try it out, it just wants a name and description. So I'll just say solution to conference. I'll say to be determined, and I'll execute that. I'll get my same 200 response. I'll get back the event that I just posted. I'll go back to my database, and now I've got that same record that I just posted from my web API in my database, without compromising the ID or any other columns that might add to this table in the future. Because now that endpoint is just expecting a name and description. And that's sort of where you want to be early on in your kind of EF experience. Is you don't want to expose your models to the consumer, because it makes your life a lot easier if you then make changes to your database. Certainly, if I now basically add any other columns, it won't automatically reflect on my consumers. And I could rename something. I could rename description in event and then have that reflect. So let's do that. So instead of description, we'll have an objective for the event. Right? So let's just run that. Of course, my model that the consumer is tied to, my add event DTO, is still called description. So I've not made a breaking change. And now if I just want to post and say, try it out, I say 1, 2, 3, 4, 5, 6, and I execute, I'll get a 500. An error has occurred while saving the interchanges. See the inner exception for details. And they're going to say to me, well, my table of events has no column named objective. Well, yeah, it has a table of events, but it's got a column called description, and I've just renamed that. So what gives? It hasn't reflected, even though I'm running migrations on startup here, but I've now renamed the column. What gives? Well, I need to tell Entity Framework that I've just done that. And this is now going to introduce kind of the step of updating your schema as you work along. I have an existing database, and I now want to change a column. So we go back to our CLI, and we say .NET EF migrations add. The same process as our initial, and we'll give this a name, and we'll say rename description on event. And it's going to look at our snapshot, and it's going to say, oh, I've got description here, but it's actually changed. And you just see it just changed right there. It thought it had description, but it actually looked at the class event and saw objective. So now it's created the migration, and it's going to say, oh, rename the column description in the events table to objective. Perfect. If I now run my application, what will happen is that I'll run those migrations, and suddenly, if I go to my database, my column is now called objective. And guess what? My post now works as I would expect. I'll get my 200 back now, no longer an error. Refresh this, and I now have 1, 2, 3, 4, 5, 6. Perfect. So that's how you deal with changes to your model. There's two parts to this. I've allowed myself to make changes to my API by having this intermediary kind of layer, if you will, in my case, a DTO, you might call it a model, whatever you might call it, it's still called description. So all my app and all my users are happy, and I don't need to worry about rolling out a new update for my app. In the back end, I've changed the column name and I'm happy with the way it is, and I've just redirected description to be objective. And of course, over time, you can phase that out and change your middleman layer as well. And I've now kind of encapsulate all my database knowledge is just in my application, and I'm not distributing it to the hundreds, thousands, the tens, the one person that's using my app. Because at the end of the day, they shouldn't care how exactly or where exactly, I'll say that with trepidation, where exactly my data is stored. If it's SQL Server, if it's Postgres, they should just care that, okay, they've got my data and they're handling it, not how my data looks. And that's kind of the beginning to managing your schema. And now that you've got an existing database, you do not want to manually change a snapshot. You do not want to delete these migrations, because they now sort of represent the almost source control for your database. And it's important that you check these into source control so that other people can apply those same migrations and have the same development experience as you do right now on the events controller. Cool. So I've got my ad, and I'm just going to work my edit. Oh, my get all. At the moment, we've just built a glorified viewer, which I've already got in my other application. But if I execute this, I'm just going to get everything in my database. And the same principle applies here. I'm exposing my ID. I'm exposing the fact that attendees are there. I don't care about this on my endpoint. I just want to know what name and what objective does my event have, right? So again, I might choose to now, for this endpoint, create another DTO. And we just want to expose the name and just expose a description. And we'll change event. And we'll change this now to go and query for our events. But of course, it's going to error because it's the wrong type. So how I'm going to deal with that? Well, before you before you materialize the query, that is to say you go away to the database and do the query, you want to transform the raw data into the usable object, event DTO in our case. And we're going to do that by projecting. So once I'm in my context, I'm attacking the events table, I want to say select, and I want to say, okay, well, every element, every event is going to go into a new event DTO. And I want the name and I want the description. Oh, sorry, the objective now. And now what I've got is a query that says, go to my database, solution context, go to the events table, select the following properties, and we'll just call this event. Select the event's name and select the event's objective into an instance of event DTO and return that to my consumer. So now if I run this, my consumer of the API will only get those two properties that I want to actually give them. And you'll see that in my response to my 200, I've got a name and I've got a description in my JSON array. Of course, in my database, I've got an ID and a column I don't want to expose to my consumer. So that's all right. That's cool. Why wouldn't I want to expose IDs though? Why am I holding away from that? Well, IDs are, of course, a unique identifier per row, but in my case, they're actually sequential. So you'll see how I was adding a couple here, and there's go 46, 47, 48. Well, the problem is if someone knows that, and it's fairly predictable state, someone can just sequentially run a script and attack you. If you've got poor security or whatever it might be, it's just not a good idea to even let yourself get into that position. Someone could just sequentially run off all those events and say, well, I know the next one might exist, and they could just, by virtue of just checking to see if I get a 200 or whatever response your API might give, they could basically dump your entire database. So you never really want to expose IDs to the real world if they're sequential. I would argue you don't really want to expose any type of ID, even to the GUID or anything. You always want to kind of create a sort of a publicly exposable ID, if you will, something friendly for a row to be identified to anyone else. So how are we going to do that? Because how I don't specifically want to give the ID away to someone. So if I'm trying to invite someone to the event, I can't just say, just type in the name, because there might be two solution one events. There might be one for JavaScript and the JavaScript server, and there might be one on the C# server. Okay, so how am I going to solve that problem? Well, I mean, this kind of comes down to architecture now at this point, but we're going to solve that problem by adding a kind of a unique friendly code name, if you will. And again, we're going to make this fully required. And that means it's not nullable. We're going to need a value, and we want a value, and we're going to share this with other people, and we're going to use this as a way of inviting attendees to our event. And again, I've made my change to the model. I'm looking at my snapshot, and again, my event class entity framework expects 3 properties. It's expecting the ID, the name, and the objective. Of course, I've added one now, so I need to tell it to go and update itself and make a migration. So we'll say add code. Might be a bit more specific than that, but for the intensive purposes of this, I'm not going to be very specific. I've actually got build errors, so that's cool. Didn't expect that one. Oh yes, I need to somehow make logic for making a code now. So our code will be a new GUID, maybe. There we are. And then we want to probably return that as well. So now we've got a sort of interesting scenario of, do we want the user to create the code, or do we want the system to create the code? Well, I want the system to create the code. So we're going to create another DTO now, and we say a response DTO, and that's going to include the code. So now, if I just want to return a new add event DTO, response DTO, I can say, well, I know it was the model name, I know it was the model.objective, and I've got my code, which is just event entity code. Instead of returning this, I'm going to return an event response DTO, and I might actually choose to use that instead of the passed in one, so I just get the objective. So now, when I'm adding one, I'm going to generate that code as well. So I fixed my build error, so now I can get on with making a migration again. That's all well and good, but I've actually got an existing data set of events already, and I've kind of I made it a required field, but how am I gonna backtrack and backdate this change to my millions of events that have happened 20 years ago? Well, I'm gonna have to write some look at SQL. I'm gonna have to change my migration, because you'll see that when it adds the code, yes, it adds it as not nullable, but it's going to just give it an empty value, and that's not good enough. So I can now make an informed decision as a developer to say, well, we're going to create a migration path for all our existing data. So I'm inside the migration, and I can modify this. I'm free to modify it. Entity framework won't rescaffold this. This code will just get checked in like a normal C# class. And I'm going to say migration build.sql. I'm going to write some SQL now. Probably the only SQL that you really have to write. You could use the C# APIs for this, I believe, but I'm going to say update events, and I'm going to set the code equal to something. Now, in my case, I'm just going to set it equal to the ID, which is ironic because I just told you not to expose the ID. But for the purposes of this, I'm just going to say, well, set the code equal to the ID. So we have something in there. And now what will happen is when I run my application, it's going to run the add column, but it's also going to run this manual SQL. I've got my application running. I'll call my events get method. I'll try it out. And now what you'll see is that if you added the code to your event DTO, you would see that there was a code on the result that, of course, I added before I ran the application. And I've dealt with all the existing data, and I don't need to worry that, okay, there was an event 2 years ago that didn't have my code. And you'll see that my code just equal to my ID, but all my data is now valid and there's no integrity problems. So I've just dealt with that. And anything new will just, well, it will use the right strategy. Of course, I could literally write anything into my SQL. I could have a random number generator. I could have my name, whatever it might be. I just chose, in this case, to have the ID. So now if I go and post to an event, of course, I'm using my DTO. So still, I only need a name and description. In this case, it's going to be solution 3. It's going to be ABC. We're going to execute this, and what we'll do in the back end is it's going to generate a code for me, and it's given me a code. This is my unique code for my event that I can now share with people. Admittedly, it's not very shareable. Maybe a hashtag BF35, whatever the GUID isn't very catchy, but it's a code nonetheless. I'm now happy to share publicly, because if there was anything wrong with that, I could just revoke it, or I could figure out that okay, it was shared this way or XYZ. And that's my database, that's persisted, and that's all cool. That's all fine. I'm happy with that. And I've persisted my code, not exposed my ID, and I'm kind of ready to roll with that. Cool. So I've got adding, I've got getting. So let's actually work on the actual attendees now. So let's rename this controller. And we're going to cheat by copying and pasting it. And we'll make another one called event attendees controller. Again, injecting our solution one context. And in this case, we're going to, well, what do we want? We want a get method which will, get me all the attendees for an event. Okay, that's fine. So immediately we know that, okay, we probably want a DTO for that, but right now I don't actually know what I want to, display. So how are we going to deal with that? Well, we're just going to bring back an event attendee for now. We're going to go to our solution one context, go to our event attendees, and then we're going to basically to list them. Now we've got a bit of a problem because I only want a specific event. Okay. So I'm not publicly exposing my IDs. I am publicly exposing a code. So I want the consumer of my API to maybe give me a code that I can kind of identify the event by, right? So how am I going to filter down just to the attendees of my event? Well, we'll get there in a moment, but we need to also be able to add an attendee as well. So let's just work on that while I think about how to solve that problem. So again, we're going to return our event attendee, add event attendee there, and we're going to say, okay, go event attendees, add model, all that CRUD stuff that we love to do, empty framework, and then return the model. And get rid of all that DTOs at the bottom. Cool. And now I have another controller. If I press F5, I'll get myself the same Swagger document. And I can say, okay, run this. And hopefully I'll have absolutely nothing. I'll get 400 actually, because the code field's required. Of course. Nothing. I'm not doing anything with code. Of course, there's no attendees either. So let's go and add an attendee. Okay, so we're going to try this out. Again, I'm exposing my entire entity model, so that's not great. So let's think about how we're going to solve that problem. So again, I don't want to be exposing my ID or my name or event ID, and now I've got a problem because I don't put event anywhere. I don't give anyone an event ID. I give them a code. So I guess I'll need some kind of object that takes in a code and a name, and I'll let my backend deal with the rest. So let's make a model. Add attendee DTO. And we know we're going to need a code, and that's the event code. So let's be really explicit. And the name of the attendee. Okay, that's cool. So let's just now make sure that we take this to our endpoint. I've now got a model, and again, because it's type safe, I haven't got the right type, so now I need to deal with the right types. I'll say, okay, attendee entity equals a new attendee, and it's going to want a couple things from me now. It's already screaming at me. It's going to want a name. I've got the name. That's not a problem. That's 2 seconds. Now it's an event ID. How is my consumer that doesn't know about the ID but knows about the code going to get the event to link up? I've got a foreign key. So if you remember, my event attendee can't exist without an event. So how am I going to do that? Well, I need to go and query for the event first. And I need to say, okay, well, I know what the code is. So let's get the event entity. And we're going to await that query again. Go to our solution context, say events. And then I want to filter down to the right event. So how am I going to do that? Well, I'm going to use link, just regular old link from C#, and I'll say where, and then I'm going to say, well, okay, I've now got access to all the properties of my event, and I'm going to say, well, where the code is equal to the model.event code. Perfect. Now I know that there should only be one event with this code. So I'll go single async. Perfect. I've now got a query that's attacking my events table, and it's saying where the code is equal to the model's event code. And now I can say, well, okay, the event ID, which is my foreign key, is equal to my entity. Sorry, event entity, equal to my event entity .id. And now I've fulfilled everything that my attendee wants to know. Of course, I only want the ID here. So again, what we did with the event, we want to do here, we want to project, and we want to say, well, I only want to select the ID because it's the only thing I need to do. And now I need to worry about doing .id because now I'm just grabbing that one property, which is my ID. And now I can say, okay, well, add the attendee to my database, save changes, and then return the model. Now if I do this, currently we have an empty database. Go to my events table, browse this, go to my event attendees, try this out. It only wants two properties, my event code, my attendee name. My attendee name is Patrick. And we're going to cheat now by just going, actually we could do this properly by going to our events, using a mobile app, for example, execute this. Got a bunch of events here, and I want to go to solution 3 because that's the next hot thing that's going to happen. I go back up, and I want to put that code in. We're going to put a breakpoint in to see what happens now. So as soon as that event fires off, press execute. Get that model in. It's deserialized properly. So you can see my code here. It's going to go away to my database. It's going to bring back an event, and you can see how I've now got an ID. So it's gone internally. It said, okay, I've got this code. I'm going to query the code. I'm going to see all the events. I'm going to buy this code, this GUID. I've now got my ID back. I'm going to create an event attendee entity. I'm going to create it. I'm going to save changes. I'm going to return it. And now, if I go to my event attendees and try this out, I'll get 400 because the code field's required. I've now got my event attendee. Perfect. Oh, this doesn't look quite right though, because I'm still exposing the whole entity, but it doesn't look quite right because I've got an event ID, which means it's gone into the database, and my relational database knows about the connections, but my event is null. Is that quite right? Is that what I want? Probably not. So let's just go have a look at the get method. So it's just doing a toList on event attendees, so can't be wrong there, but it's using this nullable navigation property. Now, by default, Entity Framework won't query other tables for you. So that is to say, I'm currently in event attendees table, but I've got associated data in my events table. So whilst I'm attacking my event attendees table, it's not going to bother going to the events table because there's no need for it. It doesn't know about it. It doesn't care. It's just going to load everything in from the event attendees table. But of course, I want to know about the event. So we're going to tell Entity Framework to what we define to is basically eagerly load an event. And we do that by saying we're going to go to the event attendees table, and then we're going to include the event. That basically means it's going to, in SQL terms, it's going to join on this event by the ID that we set down here. So now when running this, instead of just getting a null event on my Swagger UI, I'll run this, not forget the code this time, and I'll get back a whole bunch of garbage. Well, what's just happened? This is the main problem with exposing your entities over the wire. There is of course, I can turn this off, and I'm sure people will point this out. But there's obviously a cyclical cycle to my event to event attendee, which goes back to the event, which goes back to the attendees, and it's this hierarchy going on. And of course, the serializer, it doesn't know that. It's just going to infinitely go back and forth. So how do I fix that? Well, again, it's our trusted DTOs or models. And we're just going to say, okay, public record event attendee, and I say, well, I want the name of the attendee, but I also want the event name, and I might want the event code because I might want to share it out to people. So now instead of doing that sort of that include, if you will, we're going to go back to our endpoint, return that DTO. We're going to select into a new event attendee DTO. We're going to want a couple constructor things. So we want the name of our attendee. And then we're going to get the event name. And we do that by using that same navigation property. So we say event.name. Of course, it's nullable, but I know, unfortunately, this is kind of a C# to relational database thing now. I know that event's not going to be null. So I'm saying it's definitely not going to be null, but I want to get the name of it. And then I also want to get the code of it. And now what Entity Framework is going to do is going to join on that events table and grab me the name and code columns as well. And I'm doing that same sort of projection, if you will, but at a different sort of level now, because I'm going from one entity to another. And because this is a projection, I don't need to include anymore because Entity Framework is just going to do it for me. So my query slims down a little bit in C#. And if I run this now, I won't get a cyclical cycle anymore because all I'm doing is now passing back raw data that can quite easily be serialized. And I'll get back my array, and my name is Patrick, and I'm going to solution 3, and that's the event code that I can share to anyone else. Perfect. And now we have persisted some data that will run for the lifetime of however long I care to keep the file for, which in my case might be a day, 2 days, or a year. It doesn't outdate. I have now persistent data, and I can query that data. It's all happening in the controller at the minute, but you might choose to then refactor that into services and do kind of whatever you want to do in terms of kind of your actual architecture. And that is a whirlwind intro into the wondrous world of C# database access with Entity Framework core. And I'm sure, no doubt, people have got a lot of questions at me now. So let's go for it. I hope I covered everything I wanted to cover. Where do the questions start? Let's see. I can see at the very top. Do you use GUIDs for ID very often? Is that very common in EF? It kind of depends. I suppose it's entirely dependent on how you see your data go. As I said, if you use a GUID as your ID, whilst it's less optimal, less efficient to store a GUID as your primary key, it's certainly viable. I don't think you'll, unless you're really doing high throughput, I don't think you'll really notice the difference. And you could expose that, you could potentially expose that GUID, and there wouldn't, it's less I suppose it's you can less sort of compromising than an integer that just sequentially goes up by 1, or whatever it might be. Do you think it's okay to skip learning SQL and straight jump to EF? That's what I did. I sort of learned EF. You will very quickly run into problems that you don't understand with EF that will require SQL knowledge. But I would say that everything I've shown you now doesn't require really any SQL knowledge. You just need to be aware that there is stuff happening under the hood, and there is bits and pieces that are kind of going on there that might not necessarily make sense right now in terms of like, well, okay, how does a relational database actually work? But you can see here, I did that with fairly minimal knowledge. When it comes to more specialized scenarios where I'm now dealing with data migrations, such as this one here, it's like, yeah, it won't. You kind of need to know a little bit. You need to know what's going on. You won't fully get away from it, but I think for the most part, you can get away from it from very, very beginning. You can get away from it, in my opinion. Where is iRepository T? Okay. What features do you most often see misused in EF core? Is that a masked question of the repository? That's a good question. What do I see most misused? Yeah, that's kind of I think the most misused is probably people not understanding the entity framework does a lot of stuff for you without you realizing. So, for example, if I'm now grabbing some entities from here, and I just say events, and I do events, oops, and I just to list this, entity framework is going to do a lot under the hood. It's going to grab every single column from my database and every single record. And no one really understands the repercussions of querying every single record. It's basically asking for you're going shopping and you've got a list of things you want. You've got 3 items, but you're actually going to end up with basically a shopping cart of everything in the shop, and you're asked to pick just 1 or 2 items, but you've got the whole shopping cart there. Someone's already picked all the stuff for you, given it to you. Someone's done the work, and then you're only going to pick 1 item from it. So you might now say events dot, first, and you've already done your massive query for you. So I think the actual querying aspect is probably the most misused, because entity framework just allows you to do that. If you use Dapper, you'd have to write SQL, and you'd no possibility for you just to go, yeah, it's just, you have to think about it. Here, you don't really have to think about it. I mean, you could still do select star from table, no doubt. But I think it's a bit more of an informed decision at that point, in my opinion. So I don't know if that counts as a misused feature, but it's very easily kind of misused. So why aren't you doing this async? I mean, I did most of async. I just didn't do the start of async because I didn't think there's much point to it. But does that answer the question? I don't know. In the past, complex joins have been a struggle when using any tips to trigger that better experience. Yeah. So EF is known to generate code. Generate code doesn't always get it right. EF is known to create some real garbage. If you're experiencing slow queries and you don't know what's going on, what to do, the APIs in newer versions of EF Core, certainly I think it was 5 onwards, have made logging like increasingly easy. So now if I go to my context, I can basically dump everything that EF does to my console, and I can just say, well, console.write. Of course, you could insert popular logging framework into here, or do it properly via the pipeline. But for all intents and purposes, I've now got that kind of working. So I can now say await db events. And now when I start this up, I'm just going to dump everything that EF does to my console. And you can see how noisy my console has now become, because literally everything that EF is doing is now in my console. So if we just pretend that it starts here, I'm now going to execute a query which says event attendees. I'll try this out, execute that, and you see immediately it's just dumped everything to my database. And you'll see if you scan through this that the actual SQL that is generating or running, for the most part, is actually it's right there for you to see. So you can see what it's trying to do with inner join events, blah blah blah. When you start getting to bigger tables, bigger joins, more complex queries, it becomes pretty more important for you to check that kind of stuff. In terms of tips of avoiding that, I'd say your database design should be driven by what your actual sort of your requirements are. A lot of people underestimate very simple things. Like, for example, if I wanted to know how many attendees go to an event, I might choose to dynamically query that every single time and do event.attendees.count, or event attendees where the ID is that, blah, blah, blah. But what I might actually do in a bigger application, because I happen to be Stack Overflow and I need to be like sub-millisecond queries, I might choose to go to my event class and actually have a sort of a cached property, which is like number of attendees. And now, instead of joining every time I query an event, I would just go to that property. But the con to that is obviously now I need to make sure, well, every time a attendee attends my event, I need to make sure I'm recalculating that column correctly. So there's trade-offs to both things. I think a lot of people underestimate what you can sort of like normalize in a database. That's kind of what I see most people fail at. They feel like they have to have everything that's relational. In my opinion, that's completely fine to have a column like that if your requirements are basically access number of attendees, like that within a second. I don't know if that kind of answers your question, but that's sort of one of my things. And there is the option of dropping into manual SQL with EF still and just use it like a mapper. But not. It's kind of a more, I suppose, advanced talk at that point. Beyond the basics of let's just get some data in our database. Maybe some automapper. Nope. When to use async and when don't. Pretty simple answer to that. Always async. I thought DTO was a semantics for the database model, not the domain models. The way I wrote it backwards, but I do want to know what I've been wrong. I thought DTO was a semantics for the database model. What do you mean, like calling the entities like event DTO and then having that as a table? I think, is that what you mean? You just follow up and then I'll answer that question. How big do you think a project has to be before EF is relevant over something like a simple JSON file? It's an interesting question. I suppose the question is kind of, well, how long would you want to get away with serializing and then deserializing and then reserializing and then saving that file again, rather than just being able to query what you want from a specific point in a table? I mean, as you can see here, I'm literally going to a file on my own computer and I'm not having any problems. I'm not dealing with all the deserialization stuff and making sure that works, and I don't even have to worry about versioning that file because there might be updates to my application. So unless you're very certain that there's only a very small like JSON file that you're going to have, I probably would opt for a SQLite database. I mean, the likes of Discord do it. There's precedent for it. Gone are the times where EF6 or anything prior to EF6 in .NET framework would be bulky and cause concern. I think it's viewed as a pretty lightweight tool. So yeah, I think unless you're actually just really against it, I would just save my configurations to a SQLite file. There's always a debate if you use something like automapper maps to similar ones you take in the context of a professional project, which would you use? I have always and will always be of the opinion that mapping my classes manually is the way to go. I have been bitten personally by automapper twice in my life, one too many times, or two too many times actually. I know there's now, with the advent of source generators, there are actually way better libraries now over automapper, which you can go consider. Like, don't take my word for it. The reason I manually map stuff is because I don't have to worry about testing the mapping logic, if you will. Yeah, a developer can still make errors with mapping a string column to the wrong string property or whatever, but that's way less common than using automapper, which is basically a magic box that maps based on property name. And as you can see here, I've just renamed description to objective. So I would have no way of not having a breaking API without having to now configure automapper anyway. So now I'm doing basically the legwork I would have done. I tried saving by using automapper. So to me, automapper is a definite no in all cases. If it's source generated, you can see it, and it has benefits. Write the least code you can as possible is my mantra. But when it comes to knowing and seeing and being explicit about what goes into my database, I'd like to do that manually. So to build off this one, how big does an app have to become before you want to ditch SQLite for a DB server? See, you know what? SQLite's really capable, actually, and I get kind of down about people being like, oh, it's only for toy projects. It's actually really capable. Yeah, how big does it need to get? Certainly if you're Stack Overflow side, I don't think you should be going for SQLite. I don't know. It's kind of a thing of when do you want to start reaping the benefits of database, more sophisticated database engines. SQL Server, Postgres that have job maintenances, execution plans that you can look at. I believe there is actually an application that you can see the execution plan on SQLite files, maybe. But I think as soon as you drop into those lower level kind of, wow, I need to see what's actually going on my database, and I need some like scheduled tasks, I need some maintenance. I think I think you're fine. I think you'll find that pretty quickly though, as soon as you've got a consumer facing application that you probably want to be on a server, and you don't want to be on a file that just sits somewhere on even on the same server as your website. So yeah, that's my take on that. Hopefully that answers that. Is there a way to do migrations without commands? No. No. I don't think so. I think there is actually I lie, maybe. That's a lie, and there might be it might be something in EF called Power Tools. Yeah. I haven't used Power Tools since the new version. There seems to be a migrations tool. But you still have to type stuff in. So it kind of depends on what your objective is, getting away from commands. I don't think that there's a lot of overhead to these 5 words. Your mileage may vary, but yeah. Is there a way to grab the table columns at runtime? I have some tables where some of the fields are known at compile time and some aren't. We store the schema details in another table. Yes. But I would actually I'd want to know more context about that, to be honest. You could start to leverage JSON columns, which have just been fully supported in EF Core 7. Although I don't know if... I believe the Postgres driver is lacking a bit because they had an implementation before EF ever supported JSON columns, and they haven't updated to use the new implementation. But yeah, I'd want a bit more context in that one, personally. Assuming you've got a table of blob column, are you aware of any to stream as a single column without buffering into memory? I have not storing files in database. No, I don't. I haven't stored files in a database for ever. Interesting question, though. I don't know if you can stream. I don't know if you can stream a column. I don't think you can. I might try that. My one time using EF was in a benchmark that showed EF used 45 times more memory than it's using in other ways to reduce memory usage. Yeah, you're probably doing the pitfall of every, and I'm sorry to say this, I'm not. You're doing the pitfall of every beginner at EF and basically creating the entire table without projecting it, thus pulling down the entire entity, thus adding to the context tracker, thus adding to the overhead of a context and what it's actually keeping in memory, because you're not just getting an instance of your if I go to the right class, you're not just getting an instance of event, you're also getting an instance of a proxy class where EF is able to change the, to track those changes. And then you're also getting an instance added to the context class, and the context class is constantly tracking what you're doing. And then there's all this overhead that no one sees and you can't really see all the time, because EF has to somehow be able to commit all those changes back to the database in a regular C# kind of way, because you're just mutating an object. But EF has to deal with somehow updating and tracking everything. So if you post me a benchmark, I can probably show you. Right, there's a nice plugin for it. Oh, there you go. Migrations for Dummies. NT Framework Core plugin. I believe they had one for EF6, but I don't know. You can do it with raw IDEA.NET, but I haven't found a way of EF Core. Really? Huh. It's interesting. They probably don't. I'd probably go on a limb and say they don't support it. Would you recommend to use automatic project every query and optimize performance? I would not. That's my answer to that one. Yeah. Okay. I think that basically brings me to the end of it. there is so much more that you can cover, but I don't want to take up all evening. And I will do probably a part 2 to this, where we mutate some more data and build something a bit more sophisticated, and talk about testing, because as soon as you talk about testing, people want to add repositories, and I won't get into that because otherwise I'll be here for another 2 hours. So yeah, that's me done. I hope you all enjoyed it, and I hope it wasn't too rushed because I came here last minute. But yeah, it's good. Let's persist some data to the database.